So we're going to look at how we modified the existing implementation of insert as user to work with the newer methods. We'll switch over to VS Code. So in the current version, or this is a representation of the current version. If you want to see the exact diff, you can obviously go to GitHub. So the insert as user method takes a collection of S objects that you want to insert and the list of fields that you want to insert on them. And only those fields will be set. So the first thing we do is some basic input validation to make sure that we've only got got valid inputs. And then we look at the type of S objects that are stored in that array, and we check whether on that S object type we have the creatable permission, and if not, we'll throw an exception. After that, it starts to get into some of the real work of the method. So again, for that S object type of the array, it's going to use an internal cache to pull out the describe information of every single field that's accessible on that S object. So if you have 600 custom objects, 600 custom objects are going to come out into that field map. And then the next thing it does in the existing implementation is then reprocess that list to filter it down to just the creatable fields and then convert them to strings. So now we have a list of strings of which fields the current user actually has create permission to. Move on to the next step. This is one of my favorite parts of the existing implementation. It takes the entire input array of S objects and clones it, and then immediately throws away everything it just cloned. Now, to be fair, that's a shallow copy clone, but it still is like work for nothing. Next up, we loop through every single S object that came in, and we create a blank version of the same S object type. And then on that clone, or the new fresh object, the clean object, we'll set just those fields which the user has create permission to based on what we checked earlier. If they don't have permission to one of the fields we requested that they set, then they're going to get a exception depending on the operation mode. And then if they do have access to all those fields, we're going to copy the value over from the input S object to the clean S object. And finally, we insert all those S objects and using the sharing model that's been configured. Now we'll switch over to how we re-implemented this with the newer Apex methods. So again, all our input validation is the same, but then we go straight into using the new strip inaccessible method. So you notice we don't have to directly check whether they have create permission to the S object type. We can get that through saying enforce root object CRUD into strip inaccessible, and that'll throw an exception, a no access exception, if they don't have create access at all to that S object type. The other important part here is we don't necessarily need to directly create the clones of the input S object. This will do it for us, and we'll get to that in more detail later. First thing we're going to look at the strip inaccessible is have any fields been removed. Then, based on our operation mode, we may care or may not care if fields have been removed. But if we do care, we're going to look at which fields were removed. Because we didn't initially prune the list of S objects down, we're going to check, say, was the field that was removed one that we actually cared about? If it wasn't, we can safely skip it. We didn't ask to set it, it was removed. That's a good thing, carry on. But if it was one of the fields we wanted to set and it was removed because the user doesn't have create permission to it, then we're going to throw an exception. Once we're past all that, we're down to a list of cloned S objects which only have creatable fields set. But there's another part that the ESAPI requires, which is around that white list of fields. So we've created another method here just to make it a bit cleaner or a bit easier to track how it's removing or how it's reducing the object down just to that list of required fields. We can use another new method, or new since the ESAPI was last updated, the get populated fields as map, to find out which fields are actually populated on the S object in question. And the first thing we can actually do here is say, well, if we requested fields A, B, and C are set, but only A and B are actually set on the S object, then we're good to use that S object as is. It's already got only fields we requested set on it and nothing else. And that saves us having to create a whole new S object and copy over the fields. However, if that object does have a field, maybe field D is set on our input S object, then we're going to still need to create a new blank S object and copy only the requested fields. So as we start looping over the fields that we want to set on our new S object, we can use the new isSet method. We could have potentially used this fields map dictionary as well, or map, but we can just do that cleanly, and that way we only set the fields that are actually set on the input S object, and that can save us some time in certain scenarios. And again, we check, like, was there a problem actually setting that field, and throw the appropriate exception. Now, you know here, obviously this is a new S object versus the one that we passed in, so that when we come back out, we better check, did we actually create a new object and replace that in the list, the safe list of the S objects to insert. And this latter part of the method is exactly the same. We pass it into the underlying sharing model to do the actual insert.